dear students, in the previous sessions we looked at the transitivity. So where we tried to highlight the important fact in region units. In this session we are going to look at the membership patterns in the network. In particular, we are going to study two important concepts, transitivity and reciprocity. So these concepts help us understand how relationships are formed and how connections between people behave in a social network. So transitivity and reciprocity. So both of these concepts are related to relationships between groups. For example, consider three students A, B and C. If A is connected to B and B is connected to C, then we can say that is A also connected to C? Yes. So we have a transitive relationship. Similarly, we can ask whether a relationship is returned in the opposite direction. That is where reciprocity comes in. So the first one is transitivity. So the basic idea is A tends to B tends to C. If A is related to B and B is related to C, then transitivity asks whether A is related to the C. This is the reciprocity. Just remember this simple sentence. A friend of my friend is my friend. This is the basic institution behind transitivity. So that the transitivity in a social network also follows like this. So how do we measure transitivity? So one common approach is clustering coefficient. So the idea is very simple. We look at three nodes. Suppose A is connected to B and C. Now we check are B and C are also connected. If B and C are connected, we have a closed triangle. If they are not connected, we have an open structure. So clustering coefficient tells us how frequently these possible connections actually exist. Next one, global clustering coefficient. So it measures the transitivity for an undirected graph. The basic procedure is first we count paths of length 2. For example, A to B, B to C. This is a path of length 2 because there are two edges. Then we check whether there is a third edge. A to B, A to C. If A and C are connected, the path becomes closed and forms a triangle. So the basic idea is two-step path plus third edge equal to closed triangle. So this is the formula for clustering coefficient. Number of triangles into 6 divided by parts of length. So the clustering coefficient and triples. So now let us introduce the term triple. Triple consists of three nodes. These three nodes can have two edges called an open triangle, three edges called a closed triangle. Now we have a triangle which is a closed triple. So that the understanding triples carefully, suppose we have three people A, B and C. If A is connected to B and B is connected to C, we have one open triple. Now we add third connection A to C, we get a triangle. So then global clustering coefficient example. So look at the graph. So follow these steps. Identify the paths of length 2. Check whether the two end nodes are connected. Count how many of these paths are closed. Then we use those counts to calculate the global clustering coefficient. So the next one is local clustering coefficient. Now we move from the global level to local level. Global clustering coefficient tells us about the network as a whole. But sometimes we want to ask a different question. How strongly connected are the neighbors of one particular node? That is what the local clustering coefficient measures. Suppose we select node A. A has several neighbors. We now ignore the rest of the network and look only at those neighbors. Then we ask, are A's neighbors connected to each other? If many of them are connected, A has a high local clustering coefficient. If very few are connected, A has a local clustering coefficient. So the next one is structural holes. So suppose I have three friends A, B and C. I am connected to both B and C, but B and C are not connected to each other. There is a gap between my neighbors. This gap is called as structural holes. So when the neighbors of a node are not connected with each other, there are structural holes in that part of the network. So this is the example for structural hole. So this graph shows the local clustering coefficient example. So the next one is reciprocity. Think about friendship. If you become my friend, I become your friend. So the relationship is mutual. In a directed network, if A tends to B and also B tends to A, then the relationship is reciprocal. So the reciprocity measures whether relationships are returned in the opposite direction. So this is the examples of because instead of looking at a chain involving three nodes, reciprocity looks at a closed loop of length. A tends to B, B tends to A. We started from A, reached B, and then returned to A. So we have a closed loop of length. So this is the example. We examine the directed edge between the nodes. For each pair of nodes, we check whether the relationship exists between in both directions. For example, if we have A tends to B, B tends to A, then A and B are reciprocal nodes. So reciprocal nodes B1, B2, because there is a path from V1 to V2 and also V2 to V1. This is a reciprocity nodes. So we discussed the two important concepts, which is transitivity and reciprocity. Transitivity's basic idea is a friend of my friend is my friend, and reciprocity is about mutual relationship. So in the transitivity, we can use calculations, global clustering coefficient, local clustering coefficient, triples, and structural holes. In the reciprocity, we are using only transitivity, friend of a friend. So these are the two types of network measures, which is mainly focused on the friendship pattern. Okay, thank you, students.